Hey everyone, today I'm going to talk about how we can use the deque data structure to solve a sliding window problem. The sliding window problem are the problem in which a fixed or variable size window is moved through a data structure to solve the problem efficiently. First, see what is the deque data structure. Deque means double-ended queue, and this data structure is inspired by queue data structure. In queue data structure, in which the insertion take place at the end and deletion take place at the beginning. But in deque data structure, the insertion and deletion can take place from both the end. It means that we can remove or add any element f- at the beginning or at the end. So, in deque data structure, pushback function is used to insert the element at the back, and push front function insert the element at the beginning, and popback function remove the element from the end, and pop front function remove the element from the beginning, and front function will return the element at the front, and back function return the element at the end, and at function can return the element at a specific index, and size return the number of element in the deque, and empty function return a bool whether the deque is empty or not. Let's solve one question using deque data structure and sliding window technique. Given an array of size n and integer k, for every index I 0 to n minus k minus 1, find maximum of ai plus 1 up to ai plus k minus 1. As you can observe, this question requires an iteration over the array and use of subarray. So we can solve this question using the sliding window technique. Let's see. For finding the maximum value of each subarray starting at a index I and has size k, we define a function find max value of each subarray which take two parameter vector of integer and integer k, and which return the answer in a form of vector of integer where every answer I represent the maximum value of the subarray starting at the index I and has size k. So for this purpose we going to define answer a vector of integer in which we going to store our answer. A deque of integer in which we going to store the index of the answer in the non increasing order of the value present at that index, an integer n in which we going to store the size of the array. And now we're going to iterate over the array using a variable I. So first we check if the deque is not empty and the uh, value at the back index is less than the value at ith index. Then we going to pop out the element from deque from backside, and we going to repeat this condition until our deque become empty or the value at the deque dot back become greater than our value at the ith index. And after this we going to push the ith index at the back of the deque. Now you can observe that our deque data structure will contain the index of the element in the non-increasing order of the value present at that index. So after this we going to check if I is greater than or equal to k minus 1. It means that our deque data structure will contain the information about at least k element subarray. And now we going to remove any extra element from our deque. So if we going to remove any index which is less than or equal to I minus k, and we going to remove these index from the front part. So after this step we going to store our answer. So we going to push back the value present at the deque dot front. As you know that our deque data structure will contain the index of the element in the non-increasing order of their values. So we going to push back array value present at the deque dot front index. So after all the iteration we going to return the answer. Let's take one example. You are given an array of size 10 and you need to find the maximum value of each subarray which start at a index I and has size k. So here you can see n equal to 10, k equal to 3, and array is 2, 4, 5, 3, 2, 1, 7, 8, 78, 3, 1, 1. As we know that we need to start iterating over the array using a deque data structure. So now if I equal to 0, so we knowing going to this first see that our deque data structure is empty, so we going to simply insert 0 index at the back of the deque. And for the next iteration I equal to 1, as you can see that our deque contains 0 index. So first we going to check if the value present at the 0 index is less than our value present at the index 1. So it is less, so we going to pop out the 0 from our deque and put 1 from the back. And for I equal to 2, we going to check again the same condition. The value present at the index 2 is less than or greater than the value present at the index 1. So we observe that our value at the index 2 is greater than the value at the index 1. So we going to pop out the element 2. And now, as you can see that our 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 window size become 3, so we going to store our answer. So here our answer is the answer 0 equal to the array uh, uh, array deque dot front. So at the front there is index 2, so value at the index 2 is 5, so we going to store 5 in our answer. And for I equal to 3, again we going to check if the value at index 3 is greater or less. So we going to see the 3 is less than 5, so we going to didn't do anything. And now again we going to store the 5 as the answer, because the deque dot front is 2 and the array 2 is equal to 5. For I equal to 4, again we going to remove the element from the back of the deque if the value present at the index deque dot back is less than the value present at the index I. So we going to see that the value present at the back is 3 and ith index is value is 2, so we do nothing. And we going to insert 4 inside our deque. And now again we going to store the our answers. And for the I equal to 5, as you can see that our the value present at the fifth index is 1 and the value present at the fourth index is 2, so we do nothing. And but as our window size has been increasing, so we going to remove any element whose index is less than I minus k. So here I minus k is 2, so we're going to remove any element which is less than or equal to 2. So we're going to remove 2 index, and now our deque become 3 4 5. And now we're going to store our answer. The answer is the value present at the index 3, so in the array 3 equal to 3, so we're going to store our answer 3 equal to 3. And for I equal to 6, we going to check as you can see the value at the back at index 6 is 78, so we're going to pop out the index 5 because index 5 value is 1, again 4 value is 2, so we going to pop out this element. And again the value at the index 3 is 3, so again we're going to pop out this element. And now our deque contain only one element, that is 6, so again we're going to store the answer 4 equal to 78. So for I equal to 7, again you can see that 3 is less than 6. So we do nothing and simply insert 7 inside our deque. So our deque become 6 and 7. And now again we're going to store the answer. Answer 5 equal to array deque dot front, which is 6, so array 6 is 78, so 78 is our answer 5. So at index 8, again we're going to see that 3 1, so again it is less than 3, so we do nothing and simply insert 8 inside our DQ, and our DQ contains 6, 7, 8. Again we're going to say store our answer 6 equal to array DQ dot front, which is 78. And for I equal to 9, again we're going to store check if the one is less than, so it is less than or equal to, so we do nothing and simply store push back 9 inside our DQ. And now we as you can see that I minus k is 6, which is equal to dq dot front, so we're going to pop out the dq dot front. So now our dq becomes 7, 8 and 9, and again we're going to store our answer 7 equal to the array 7, so which is array 7 is 3. So at the end we get all the answer. Don't forget to practice this concept, code, compete, and win.